if a direct transfer is occurred, right? So what will be the change of EMF of that particular concentration cell? We are going to find out. So we are going to find out, right? So once again. Right. So I am going to share my notes, right? Is it visible to all?
Visible, sir. Visible.
Okay, fine. Otherwise, shall I zoom or shall I decrease little bit? Just see,
Okay, sir.
it's okay.
Yes, sir.
Okay, right. Right. So just we'll little bit discuss about yesterday's class, then we'll move on to the today's class. Right. Concentration cells without transference. Concentration cells without transference. Without transference means there is no direct transfer of ionic species from one electrolyte to other electrolyte, even though the potential is developed. That developed potential can be measured. So to measure that potential, to construct the concentration cells without transference means without liquid junction potential, we must select two electrodes and one electrolyte. That one electrolyte must be with different activities. So here HCl is an electrolyte solution with different activities A1 and A2. A1 and A2 are the two different activities of HCl, and the two electrodes are hydrogen electrode and silver chloride by silver electrode. That becomes chloride electrode. So that two electrodes we must be selected to construct the concentration cells without transference, right? So here see, consider one cell with activity A1. So that means hydrogen is dipped in HCl, whose activity is A1, and which is connected with the chloride electrode, that is silver chloride by silver. So whenever the two electrodes will be there, one will be undergo oxidation, the other will be undergo reduction. Therefore, the redox reaction will take place. So what was the oxidation process means? Hydrogen is involved in oxidation that lose one electron. That electron is gained by the silver chloride. So that will give silver and Cl minus ions. If we consider the overall cell reaction by combining of these two reactions, we'll get overall cell reaction. So that here we have to see. So this is the overall cell reaction. What was that means? This hydrogen will be involved in oxidation, then silver will be involved in reduction. So this is the oxidation and this is the reduction. Both oxidation and reductions are take place in a single reaction. S. Venkataram, please mute
Yes, sir.
yourself. Yeah, disturbance is there. Oh, right. So hydrogen is involved in who is Redmi Note 7? So hydrogen will be involved in oxidation. Silver chloride will be involved in reduction. So if we apply the Nernst equation to this, E cell is equals to E naught cell minus RT by F ln activity of HCl. Because this is the only concentration we will consider. Ag is the solid, for solids activity is 1. AgCl is the solid, for solids activity is 1 unity. So then H2 is gas, for gases also activity is 1. Therefore, here A1 of HCl. So that will be E1 is equals to E naught of HCl minus RT by F ln activity of HCl. This is the equation number 1. So the same conditions applied for activity A2. The same conditions means, so the hydrogen electrode is dipped in HCl solution whose activity is A2. Then that is connected with the silver chloride by silver electrode. Therefore, hydrogen will undergo oxidation. Then silver chloride will undergo reduction. Both oxidation and reductions are takes place in a single reaction that we will get as overall cell reaction. So this is the overall cell reaction. So what about that means half of H2 plus AgCl gives rise to Ag plus A2 of HCl. In this case, also hydrogen is involved in oxidation and a silver chloride will be involved in reduction. Therefore, we can apply the Nernst equation to this equation. We'll get equation number 2. E2 is equals to unit of AgCl by Ag minus RT by F ln A2 of HCl. This already yesterday completed, right? So that's why I am going a little bit fast. So then I will become slow while new topic will be started. Okay. These two are having means with activity A1 and activity A2. Both are having same reduction potentials. We know that the overall cell EMF is obtained by subtracting of same reduction potentials. Therefore, equation 1 minus equation 2. So we have to do equation 1 minus equation 2. We'll get this equation. That is cell is equals to RT by 2F. RT by 2F. 2 means these are the 2 is the number of electrons, right? So for one activity, one electron will be there. For another activity, A1 and A2 will be there, different activities. So that's why 2 electrons are varying in between the electrolyte solutions of activity A1 and activity A2. So therefore, E cell is equals to RT by 2F and A2 by A1. A is nothing but activity. So that can be defined yesterday. Activity is equals to activity coefficient. Activity coefficient into concentration. So this is the activity. That activity is defined as concentration into activity coefficient. Concentration into activity coefficient. So here A means what? Activity of HCl. 2 ions will be there. So previously only 1 ion will be there. Here side will be there. For 1 ion, activity of Zn plus 2 is equals to gamma of Zn plus 2 into m of Zn plus 2. But here 2 ions are there. For HCl, m1 gamma 1, for H plus, for Cl minus m1 gamma 1. Therefore, m1 gamma 1 whole square we will get, right? In the previous chemical cells with transference, the activity is applied for individual ions like zinc plus 2 and copper plus 2. But here we applied for electrolyte solution consisting 2 ions. That's why M1V1 into M1V1. That is M1V1 square. Like similarly for activity A2, that is M2V2 square. M2V2 square, right? So these two values are substitute in above equation, right? So we'll get RT by 2F, we'll get this equation by upon substitution. E cell is equals to RT by 2F ln M2 gamma 2 square by M1 gamma 1 square. So that will be modified with, right? So that will be modified with M2 gamma 2 by M1 gamma 1 whole square. These two will come front side, right? So therefore 2 get cancelled. Therefore we can get this equation. So this will be even further separated. This equation will be further separated, means concentration and activity coefficients will be separated. So finally we'll get this equation, that is E cell is equals to RT by F ln M2 by M1. Capital M we have to write here. So fortunately, so one of your friend mentioned small m, but capital M2 by capital M1 plus RT by F ln gamma 2 by gamma 1. This concentrations ratio is known. R is gas constant, known fixed. T is the temperature is fixed. F is the number of Faradays are fixed. This E cell is obtained by combining of the two electrodes. Therefore, by the substitution of all these things, we can find out the activity coefficient ratio. With the help of conclusion of this concentration cells without transference, the activity coefficient ratio can be determined. Right? Is it clear?
Yes, sir.
Yes, yes, that's right. So today we discussed about the concentration cells with transference. So the meaning of with transference means direct transfer of ionic species. Means either cations are transferred from one electrolyte to electrolyte or anions are transferred from one electrolyte to other electrolyte. So because the ionic species is transferred, how the potential will be developed? That developed potential we are going to measure with the help of application of Nernst equation, right? So that we have to see how to construct the concentration cells with the transference, which type of electrolytes and what type of electrodes we can use, right? With the help of that, how we have to apply the Nernst equation. Upon application of Nernst equation, how we'll get the result. Okay, right. So this is the thing. The EMF is developed due to the transfer of ionic species. Ionic species means two type of ions will be there. One is the cation and other is the anion. Either cation will be transferred or anion will be transferred from one electrolyte solution to another electrolyte solution, which are having different activities. For example, here, one electrolyte solution, whatever is the electrolyte solution whose activity is A2. The another electrolyte solution will be there whose activity is A1. I am going to say that A2 is always greater than A1. Means the activity 2 solution will be more compared to the activity A. Therefore, at that time, the ionic species is transferred from A2 to A1. Ionic species, how it becomes transferred means from high concentrated solution to low concentrated solution or from high activity solution to low activity solution. High activity solution to low activity. So one of the condition we have to select that is A2 is greater than A1. A2 is greater than A1. That we are going to say here. HCl is an electrolyte solution is considered with different activities that is A1 and A2. The same HCl electrolyte here also we have to use with different activities A1 and A2. Then this is the condition we have to apply. So what is that condition? A2 is greater than A1. We are going to assume that A2 is having more activity compared to A1. Some of the ionic species is transferred from activity A2 to activity A1. Higher activity to lower activity. At that time, the overall cell EMF can be considered as E1 plus E2 plus EJ. EJ can be written as liquid junction potential. As yesterday we told that, so whenever the ionic species is transferred from one electrolyte solution to other electrolyte solution. So what is LJP means, right? Here I am going to draw. So these are the two solutions which are separated, right? So this is the A2 and this is the A1. Okay. So the ionic species is transferred from A2 to A1. For example, anions are transferred. Here the positive charge will be deposited, right? So here the number of negative charges will be increases. Therefore, it can be developed potential at the junction that is called liquid junction potential. So due to transfer of ionic species from one electrolyte solution to other electrolyte solution, some of the ions which are deposited across the junction, So there's some potential will be developed. That potential also we have to consider. Yes.
Kindly one more time, sir. LJP, liquid junction potential.
One more time.
Sir.
Right. Right. So just to wait, I can use. Right. I have to use the blackboard. Okay. Here only I will explain. Right. So what is the LJP, liquid junction potential means? Right. So clearly observe. So this is the compartment, two compartments which are separated with one junction. So here activity of one solution is A2. Here activity of the same electrolyte solution with the A1. But we know the condition, that is the A2 is greater than A1. Some of the ionic species directly transferred. Some of the ionic species directly transferred from A2 to A1. Here, I have to say some of the ionic species is directly transferred. Ionic species means what? Either positive ion or negative ion. Positive ion or negative ion. If positive ions will be moved from A2 to A1, one positive will be moved means one negative will be more here. That negative is deposited at the junction. Another positive ion will be transferred, another negative ion, another negative ion. Like that, how many number of ions are transferred? The same number of opposite charged ions are deposited here. So once plus number means positive number is transferred here, here the positive number will be increases. So these positive numbers are also deposited at the junction. So due to deposition of these positive and negative ions, this may develop potential. These developed potential can be considered as the LJP, liquid junction potential. The simple LJP, liquid junction potential, that can be eliminated by using salt bridge. What was the rule of the salt bridge? If you connect the salt bridge, right? If you connect the salt bridge here, so what will happen? So this salt bridge may consisting both positive and negative ions. These will be neutralized, these all ions. These all ions will be neutralized. Therefore, no more ions are deposited at the junction with the help of utilization of the salt bridge. This is the salt bridge, right? So with the help of utilization of the salt bridge, no more ions are deposited at the junction. Therefore, we can eliminate the junction potential with the help of utilization of the salt bridge. Right. Is it clear?
Yes, sir.
Yes. Okay. The next step will be there. So that is that, right? So see here, the liquid junction potential LJP can be eliminated using salt bridge. By using salt bridge, that will be neutralized the deposition of the ions across the junction. Therefore, no liquid junction potential. Therefore, Eg becomes 0. Right? So we will discuss in detail after completion of this immediate LJP. Don't worry. Okay. So once again, I will remind that LJP after completion of this topic. Right. So then LJP can be eliminated while using salt bridge means, therefore E cell is equals to E1 plus E2. E cell is equals to E1 plus E2, right? So therefore now consider the cell. Here also same, we are using HCl is an electrolyte solution. HCl is an electrolyte solution whose activity is A1 and A2. A1 and A2. So now consider one activity, right? So what we said that some of the ions are transferred. Some of the ions are transferred from one activity to another activity. For example, H2 gas atmosphere will be converted to the H plus electron. Activity is A1, right? So clearly listen here. The activity of H plus is A1, right? So first initially hydrogen is involved in oxidation. These electron will be gained by the H plus ions which are present in the activity A2. Okay. So here I have to draw that again, right? So here H plus, this is the activity A1, this is the activity A2, right? So here activity A1, one electron will be released by the hydrogen. This electron will be transferred to A2, right? So that A2 also having hydrogen ions. These A2 hydrogen ions are absorbing that electron that will be converted to the hydrogen of H2 gas atmosphere, right? So means from one electrolyte solution, hydrogen is involved in oxidation. The adjacent electrolyte solution always involved in reduction. So both oxidation and reductions will be takes place by hydrogen only. So if we consider the overall cell reaction, this is the overall cell reaction, that is H plus of A2 to H plus of A1. What it represents means some of the H plus ions are transferred from activity A2 to activity A1. Understand? So this is the equilibrium may represents. This is the equilibrium may represents. What it represents? These are the H plus ions are transferred from activity A2 to activity A1. Understand? There is a direct transfer of ions. Direct transfer of ions from A2 to A1. That condition already we applied previously, right? But how many number of ions are transferred? So that will be how many number of ions are transferred. That can be explained with the help of its transport number, right? So what was the condition we have to apply here? If 1 Faraday of electricity, 1 Faraday of electricity is applied, 1 Faraday of electricity is applied, in which T plus transport number of cations are transferred from activity A2 to activity A1. What it concludes means how ions are transferred from one electrolyte to other electrolyte means that is application of 1 Faraday of electricity. If 1 Faraday of electricity is applied, how many number of H plus ions are transferred from activity A2 to activity A1? That number can be represented with its transport number, that is the Ts. T plus represents cation. T means transport number, plus means that represents the cation. So therefore, this equation, right? So this H plus of A2 is equilibrium with H plus of A1 will be considered with like this, right? What is T plus number of H plus of A2 to T plus number of H plus of A1, right? Initially, H plus ions are transferred from A2 to A1. But how many number of H plus ions are transferred upon application of 1 Faraday of electricity? That is its transport number T plus, right? The T plus will be multiplied for both sides, right? T plus. And when the positive ions are transferred, automatically some of the negative ions also transferred. The negative ions transport number, that is the T minus, Cl minus T minus of Cl minus ions are transferred from A2 to A1. How many number of hydrogens are transferred from one activity to another activity? That is higher activity A2 to lower activity A1. So, for example, 10 number of H plus ions are transferred. Its transport number is T plus. 10 number of Cl minus ions are transferred. Its transport number is the T minus. T minus means negative ion transport number. T plus is the positive ion transport number. The sum of these two transport numbers are must be equal. That is T plus T minus is equals to 1. Therefore, T plus is equals to 1 minus T minus. T plus means positive ion transport number that should be expressed with a negative ion transport number, right? So that becomes 1 minus T minus of H plus of A1. So whenever the transport number, actually H plus ions are transferred from A2 to A1. So which represented with the T plus transport numbers. But here what we are doing, those H plus ions are representing with the opposite charged transport number, that is the T minus. At that time, it becomes reverse, that is A1 to A2. A1 to A2. Therefore, 1 minus T minus of H plus of A1 to 1 minus T minus of H plus of A2. Right? So keep this in mind. So whenever same transport number we are representing, that is transferred from A2 to A1. Ion is the H plus, means cation, but we are expressing with anion transport number. At that time, that becomes reverse. Therefore, A1 to A2. అప్పుడు ఏమైతుంది A1 to A2 కి ట్రాన్స్ఫర్ అయిపోతుంది. How many number of H plus ions? 1 minus T minus number of H plus ions. 1 minus T minus number of H plus ions are transferred from H plus of activity A1 to activity A2. Right. So overall here, how many equations will be there? Right? Equation 1. What is the equation 1? So that is, except this T plus, that is the equation 1. We wrote that that is H plus of A2 to H plus of A1. That is the equation 1. And this is the equation 3 and equation 4. The sum of equation 1 and equation 3 and equation 4. We are adding equation 1, equation 3 and equation 4. So what we will get by adding those all equations, right? Right, see. Simple adding means 3 equations will be there. 3 equations left hand side will be right, 1 left side. Right hand side will right side, right? With equilibrium condition, how many will be left hand side? All will be right left. How many will be right hand side? All will be right, right? So this is a little bit disappear, means in the first equation H plus of A2 will be there. In the third equation T minus Cl minus of A2 is there. In fourth equation 1 minus T minus of H plus of A1. These all are left hand side. Then H plus of A1, T minus Cl minus of A1, 1 minus T minus of H plus of A2. These all are right side, right? So now we are simplifying, means this will be expanding 1 minus T minus of H plus of A1, that will be written as H plus of A1 and T minus of H plus of A1. So this is also same, 1 minus T minus will be expandable. Therefore, these all H plus of A2 here H plus of A2 right hand side, H plus of A1 right hand side, H plus of A1 left hand side, all becomes cancelled, right? So means same sign with the same ions with the same activity will be there. That becomes cancel. After cancel all those things, we will get only simple ions that are only these, right? Means T minus Cl minus of A2 minus T minus H plus of A1 equilibrium with T minus Cl minus of A1 minus T minus of H plus of A2. So this A2 will be moved left side, right? Minus becomes plus. This A1 will be moved right side. This minus becomes plus. Therefore, same transport numbers, same activities, but different ions. Therefore, T minus HCl of activity A2, then T minus HCl of activity A1. Upon simplification, simply we will get this one. So T minus activity of A2 of HCl to activity of T minus activity of A1 of HCl. Now we apply the Yr-Msc equation. E cell is equals to E naught cell means hydrogen electron that becomes 0. Then minus RT by F ln A1 right hand side is the A1 by A2 of T minus. T minus is the its transport number that will come power. Because so the number of moles, if we consider this is like number of moles as in Yr-Msc equation, the product concentration, product activity power T minus. This T minus will come front side. So this T minus that will come front side. Therefore, we'll get the equation, right? We'll get the equation that is E cell is equals to T minus of RT by F of ln A2 by A1. So, but A2 by A1, A2 is activity of HCl, A1 is the activity of HCl. So, which will be converted into its activity coefficients, and simplified. So that above equation will be this one, right? See, so this is the equation we got this equation. A1 is equals to M1 gamma 1 square because A1 means activity of HCl who's consisting two ions. One is the H plus and other is the Cl minus ions. That's why M1 V1 into M1 gamma 1 into again M1 gamma 1. Therefore, M1 gamma 1 square. A2 also M2 gamma 2 square. These two will be substituted in this equation that is A2 by A1. So T minus RT by F ln M2 gamma 2 square by M1 gamma 1 square. This becomes A2 square. Then these two will become front side and expanded up that ln logarithm. So we will get this final equation. This is the equation is represents the concentration cells with transference.
Sir,
As
here square 2 will be multiplied to T also and in RT also. No?
2. This T minus, these all are numerators only. 2 is the numerator, T minus is the numerator, RT also numerator. Not here 2T minus. So this we have to write like this, right? So students are done mistakes. This is the 2 into T transport number of negative charge. Just this is a negative. And 2T minus into RT divided by, yeah, this is that equation. Okay. Not this is minus, right? So this is the T minus only.
Yes, sir. Yes.
T, yeah, T minus multiplied with RT by F. Here also T minus is multiplied with RT by F. Okay. Understand?
Sir. Yes, sir.
Yeah. So 2T minus into RT by F ln M2 by M1 plus ln of gamma 2 by gamma 1. So this transport number is appeared in only this one equation, that is the concentration cells with transference only. In another three equations, we didn't get transport numbers because a direct transfer of ion will be there. How many number of ions are transferred? That number is considered as its transport number, right? So these are the four equations like concentration cells with transference and without transference, chemical cells with transference and without transference. Now, with the help of this, we are going to find out the liquid junction potential. Liquid junction potential, right? So, right now you'll get a clear idea about the liquid junction potential, that is the LJP. Okay. What is the liquid junction potential, right? Right. Is it visible to you while I am drawing?
Yes, sir.
Yes, sir.
I am drawing some diagram. Is it visible to you?
Yes, sir.
Yes,
Okay,
sir.
right. So see here, what is the LJP, right? So this is the junction. So this is the what? Junction, right? This is the junction. So whenever a direct transfer of ionic species will be there. This is the second compartment, means this is the activity 2, this is the activity 1, as we considered the previous concept only, right? So the some of the ionic species is transferred from activity A2 to activity A1. Activity A2 to activity A1, right? So which ions are transferred? H plus ions are, one H plus ion is transferred, one negative will appear, right? So the negative balance will be there. So that negative will be deposited here, right? One more H plus ion is transferred, another negative. One more H plus, another negative. One more H plus, another negative. One more H plus, another negative. But 5 H plus ions are transferred from 2 to 1, means here 5 positive more. That 5 more positive numbers will be
Sir,
deposited at the junction. Yes.
sir, but activity 2 is transferring that
Ah,
electron to activity 1. Na? So it should be plus, sir, and it should be minus, opposite. But you are telling this side minus and this side plus.
activity A2 to electron, not I am telling not electron. Ion is transferred. H plus ion is transferred,
Okay, okay, sir.
not electron.
Right,
H
sir.
plus ion is transferred. Means, for example, here HCl will be there. Okay, right? So
Sir.
listen carefully. HCl is there. This is H plus and Cl minus. H plus and Cl minus. This H plus ion is transferred. Then here bacha hua Cl minus. That is the negative. Understand?
Yes, sir. Yes, sir. Thank you, sir.
One more H plus is transferred. One more negative charge will be here. Another H plus is transferred. Another negative charge. For example, Cl minus ions are transferred. Cl minus ions are transferred. Here this becomes positive. Understand? So this becomes positive. If Cl minus ions are transferred, these all are becomes positive because the negative ions are transferred. These all are negatives. Whatever it, positive and negative charges which are deposited at the junction, that is called liquid junction potential. Means the potential will be developed across the junction. That potential is called as liquid junction potential. Whether the positive ion is transferring or negative ion is transferring, whatever it. Understand?
Yes, sir. Yes, sir.
Yes. So that we have to see in the sentences manner simply, right? The potential is developed due to the transfer of ionic species from one electrolyte solution to another electrolyte solution across the junction, which is denoted by EJ. So that means the potential is developed, right, across the junction is known as LJP. This is called LJP. Okay. This is called LJP. What is LJP means? The potential is developed. The potential is developed. When the potential is developed due to the transfer of ionic species from one electrolyte solution to another electrolyte solution across the junction. That potential is known as LJP. That is denoted with EJ. Right? This is the definition of the liquid junction potential. So that liquid junction potential can be easily eliminated with salt bridge because, right? So see one more time, right? Here liquid junction potential means Here some negative charges will be deposited, negative charges. Here some positive charges will be deposited, right? So this is the potential. So once we may use the salt bridge consisting both positive ions and negative ions. If left side negative ion will be more, the positive ions which are coming from the salt bridge and neutralized them. Here positive will be more, the negative ions from the salt bridge will come and neutralize them. Therefore, the potential will be zero at the junction with the help of salt bridge, right? So that's why the liquid junction potential can be eliminated by using salt bridge. Simply we can say that. Okay, right. So for which, what we have to take? How to get the liquid junction potential, right? Very simple. See, one cell considered with the junction potential, right? One is cell means with the transference. A chemical cell or concentration cells with the transference means E1, E2 and EJ. Three will be there. Another one with without liquid junction potential. Only two, E1 and E2. This E1 and E2 can be subtracted, will get EJ. That is very easy. ఒకటి ఏంటి సెల్ విత్ జంక్షన్ పొటెన్షియల్ తోటి తీసుకోండి, ఇంకొకటి వితౌట్ తీసుకోండి. వీటిలోకించి వితౌట్ తీసేయండి, we will get the liquid junction potential, right? In another way, one cell with transference means it will give liquid junction potential. Another one is without transference. The subtracting of these two, that will give EG. Very simple, right? So that we'll see. This is right. Now consider the cell. Student cell etla consider chestunnam. Consider the cell with transference. With transference means there is a direct transfer of ionic species. And EMF of this cell can be written as EX is equals to E1 plus E2 plus EJ. E1 plus E2 plus EJ means it has liquid junction potential. Okay. And its equation, just now we derived that E cell is equals to what? 2T minus RT by F ln gamma 2 M2 by M1 gamma 1. This is the equation is what? Concentration cell with transference. Concentration cell with transference. That is the one equation we considered. Okay. So this is the equation number 1 and 2. Now we are considering another equation. Right? So that is, consider the cell without transference. One is with transference, EJ will be there. Now this is the without transference, there is no EJ. Therefore, this will be subtracted from that. We will get only EJ, right? So this is the EY equation, the EX equation. Therefore, EJ is equals to how we'll get EJ means the subtraction of, this is the with liquid junction potential, this is the without liquid junction potential. The subtracting of these two, even get cancelled. Therefore, finally we'll get EJ. Clear? Without transference equation is this. RT by F ln M2 gamma 2 by M1 gamma 1. With transference equation also there. So therefore, by subtracting of those two equations, we will get liquid junction potential. One is with transference, other is the without transference. Subtracting of both will get EJ. Right? So this subtraction will see. This is the equation of with the transference. What is that equation? 2T minus RT by F ln M2 gamma 2 by M1 gamma 1. This is the equation for without transference. That is, with no liquid junction potential. RT by F ln M2 gamma 2 by M1 gamma 1. So here, this is the common term will be there. This entire is the common in both equations. Okay. So therefore, we have to take common. We'll get 2T minus 1. 2T minus 1. So by simplifying that 2t minus minus 1, so that I will show here, right? Right. So this t plus t minus is equals to 1, we know. Then 2t minus minus 1. 2t minus minus 1, right? So here 2t minus this is 2t minus minus 1, right? Just make it. So this you have to write there 2t minus minus 1, right? This is the in place of this. Okay. So 2t minus 1 means t plus t minus t plus t minus. Therefore, 2t minus minus t plus t minus. Therefore, 2t minus 1 is equals to will get t minus and t plus, right? So here not clear, right? So I will write here, just see. Okay. So what? Uh, 2t minus minus 1. This is the equation actually. In place of this, what we are going to write means 2t minus of t plus t minus, because we know that t plus t minus is equals to 1. T plus t minus. T plus t minus. If we apply minus to this, minus t plus and minus t minus, we will get. Okay. So ఒకవేళ మైనస్ అప్లై చేసినాం అనుకోండి ఏమైతుంది? So we'll get a minus by apply minus. So this is the t minus t plus and minus t minus. Here 2t minus is there. Here 1t minus will be there. From that we'll get t minus only. 2t minus like 1t minus with only 1t minus. Then minus of t plus. Therefore, so this is the equation we will get. T minus minus t plus is getting in place of 2t minus 1 is equals to t minus minus t plus. That will be substituted here, right? So that will be substituted here. So then we'll get our final equation, right? That is Ej is equals to the 2t minus will be substituted in above equation. This is the Ej, liquid junction potential. Ej is equals to T minus minus T plus of RT by F ln M2 gamma 2 by M1 gamma 1. M2 gamma 2 by M1 gamma 1. Right. So just wait. Right. Okay. Am I audible? Yes, am I audible? Okay.
Yes, sir.
So this is the equation we got. Ej is equals to t minus minus t plus, right? So these are the conditions. If t plus is equals to t minus, what
Sir,
about Ej?
sir,
These two are same. Yes, yes.
2t minus 1 is equal to t minus minus t
Minus t
plus.
plus. Yeah.
So, sir, how we got, sir, E is a mean is equal to t minus minus t plus RT by F ln M2 V2 by M1.
This equation. Just wait. Right. This is the equation we have. Ej is equals to 2t minus minus 1 of RT by F ln M2 gamma 2 by M1 gamma 1. This 2t minus 1, right, here minus, we use it to forget minus,
Yes, sir.
right?
Got it, sir.
Right. Right.
Got it, sir.
Yeah. So
Got
these
it.
two, t plus plus t minus is equals to 1. But 2t minus minus 1 means instead of 1, we have to write t plus plus t minus. Then simplifying, we'll get this equation. This will be substituted in place of this. Okay. Therefore, we'll get
Yes,
this final equation. Okay.
sir. Thank you, sir.
Okay, fine. Right. Then simplifying of this equation, right? Simplifying of this equation, that we'll see. If this t minus and t plus is equals to same, means t minus is 1, t plus is 1. 1 minus 1 means 0. Therefore, Ej becomes 0. Liquid junction potential is 0. That's why in a salt bridge, we are using KCl solution because K plus transport number is the T plus, right? So Cl transport number is the T minus. These T plus and T minus are nearly same. Whenever the solution which is used in the salt bridge, which is having same transport numbers, whenever the same transport numbers will be there, at that time, no liquid junction potential. That's why with the help of salt bridge, we can eliminate easily liquid junction potential. All of you understand?
Yes, sir.
Yes, sir.
Yes. Why the potential can be easily eliminated means this is the reason, right? So, ఏం లేదండి simple. So, can I use little bit Telugu, right? Otherwise, I will explain again in English. Simple గా కొన్ని పాజిటివ్ అయాన్స్ ఒక దగ్గర నుంచి ఇంకో దగ్గరికి పోతున్నాయి. అంటే ఇక్కడ నెగటివ్స్ మిగిలిపోతున్నాయి. ఈ నెగటివ్స్ ని న్యూట్రలైజ్ చేయాలంటే పాజిటివ్ అయాన్స్ రావాలి. ఒకవేళ ఇక్కడ పాజిటివ్ అయాన్స్ పెరిగినాయి, ఈ పాజిటివ్ ని న్యూట్రలైజ్ చేయాలంటే నెగటివ్ అయాన్ కావాలి. ఆ వచ్చే అయాన్ ఎట్లుండాలంటే పాజిటివ్ అయినా నెగటివ్ అయినా సేమ్ స్పీడ్ తోటి పోయేటట్టు ఉండాలి, రైట్? So these K plus and Cl minus are having same transport numbers, same speed they can move, right? Whatever is the ion in the solution, that doesn't matter. But K plus ఎంత స్పీడ్ తోటి పోతుందో Cl minus కూడా సేమ్ స్పీడ్ తోటే వెళ్ళిపోతుంది. ఎన్ని K plus వెళ్ళిపోతే అన్ని Cl minus వెళ్ళిపోతాయి, right? So that is the reason. That's why we can eliminate easily liquid junction potential with the help of using salt bridge. Okay. Right. Then, for example, its transport numbers are not equal. Means T plus is more compared to T minus. Well, KCl కాకుండా any other electrolyte solution we may use it in the salt bridge. For example, cation number will be more, right? అంటే cation చాలా స్పీడ్ గా వెళ్ళిపోతుంది, న్యూట్రలైజ్ చేస్తుంది. మరి anion అంత స్పీడ్ గా వెళ్ళదు. అప్పుడు what is the liquid junction potential? That becomes negative. Means the negative charges are deposited across the junction. So that value becomes only negative. If T plus is less than of T minus, means negative ions transport number will be more. At that time, Ej becomes positive. ఏం లేదు, ఈ values ని ఇక్కడ substitute చేయాలి, right? When Ej is 0 means these two transport numbers are same. When T minus is more, more minus less, that becomes positive. Ej is positive. T minus is less, T plus is more, less minus more, that will give negative. Ej is negative, right? So this is the representation of liquid junction potentials with the help of its transport numbers. Therefore, the liquid junction potential can be easily eliminated by using salt bridge, right? Here statement will be there. Ej is eliminated by using salt bridge. The salt bridge consisting KCl solution whose cation and anion transport numbers are equal. That is T plus and T minus are equal. Due to this reason, we can get the liquid junction potential 0. So that's why whatever is the system we may establish, right? So we have to utilize the salt bridge, therefore the liquid junction potential can be eliminated. That is the one of the best application of EMF experiments, right? So the another one will be there, determination of pH from EMF measurements. One is liquid junction potential, other one is the determination of pH. One more will be there, determination of solubility product, right? Solubility product also there, right? Determination of solubility product. Then further potentiometric titrations and some other topics will be there. So those topics we'll discuss in the next class. Will be discussed with next class. Okay. So I think you people have next class, immediate paper 4 will be there. You have to join in the paper 4, right? The determination, just you have to see what are the remaining topics. Determination of pH from EMF measurements, right? So then quinihydron electrode, then here is the question is there. This is the heading only. Determination of solubility product of sparingly soluble salts from EMF measurements. This is the question only, right? So one is the pH, second one is the liquid junction potential, third one is the solubility product, fourth one is the potentiometric titrations. Out of these 4 questions, definitely you will get one question in the examination. 100% you will get one question, right? Now liquid junction potential is completed. So the determination of pH will discuss later, and the solubility product also will discuss later. So after that, potentiometric titrations will be there. Potentiometric titrations, 3 type of potentiometric titrations are there: acid-base titrations, redox titrations, and precipitation titrations. So then after that, precipitation titrations, after that, equilibrium constant. Then these are the types of electrodes. What type of electrodes we are utilizing? Types of electrodes will be. So then caramel electrode, hydrogen electrode, then gas electrode, quinihydron electrode, right? After that, this is the new concept, that is the electrode polarization. Okay. So I think next 2 classes, we will wind up this chapter, right? We have to speed up from the next class onwards. So what you people do, one thing means, I can share the notes right now only. You have to write the notes of today's, up to today's class. If possible is there, you have to write even further notes also. Guys, once you have written, so while I am explaining that same terminology, you will understand the concept. Yes, is it clear? I think next class will be on Saturday. Next Saturday will be there. So this 7 days time will be there. You have to spend at least 2 hours, right? It will be enough to write 2 hours of today's and yesterday's class. Okay. Yes.
Yes, sir.
Okay,
Yes.
sir.
Anything else? Anything else? Right. I am going to share the notes, right? So yesterday, sir messaged me. Yeah. I am sharing that notes. You have to
Sir.
collect from that, sir.
Sir,
Yeah.
sir, one request. Can
Yes,
you
yes.
give one class on entropy, sir, for Sunday?
One class?
On entropy changes, sir. Entropy.
Entropy. Okay,
Yes.
okay, fine. Okay, I'll take care.
Okay, sir.
I'll take one class and be on line. So I'm going to share the electrochemistry notes. Right. Just you have to check once. I sent the notes to you, right? So you have to distribute to your friends and okay. So make it to write the notes, right? So then you have to wait for the next class and so join in the next class meeting. Right now, I am going to conclude the meeting, right? So all of you take your lunch and join in the next class. Okay.
Okay, thank you, sir.
Okay.